Welcome to Ask and Learn.
We are given sets, and we are asked to construct non-deterministic finite-state automata and recognize each of these sets. So the first set we're given is the set containing lambda and the string 0. Let S0 be the start state. Then the machine should accept the empty string lambda, so S0 should be a final state. If the input is a 0, then we'll move on to another final state, since 0 should be accepted. Call this final state S1. And from this, we've obtained a non-deterministic finite-state automaton that will recognize the strings lambda and 0, but no other strings. In part B, we're given the set 0, 1, 1. Now, let S0 be a start state. Since the empty string lambda should not be recognized, it follows that S0 should be a non-final state. Now, if the first input is a 0, then we'll want to move from S0 to a final state S1, because 0 should be accepted by the machine. Now, if instead first input is a 1, then we'll move from S0 to a non-final state S2. Don't remain at S0 because this would imply that any string which is a sequence of 1s should not be accepted, while 1, 1 should be accepted. Now, suppose that the next input is a 1. In other words, we have a 1 at S2, and we'll move from S2 to a final state, which we can just use the same final state from before, S1, because 1, 1 should be accepted. And so the resulting non-deterministic finite-state automaton recognizes only the strings 0 and 1, 1. In part C, we're given the set 0, 1, 1, 0, 0, 0. In a sense, we'll be adapting the previous machine to make this machine. So once again, we'll let S0 be a start state. And since lambda should not be accepted, we have that S0 is again a non-final state. Now, if the input is 0, then we'll move from S0 to a final state S1, since the string 0 should be accepted. Now, if the input is 0, at S1, then we'll want to move from S1 to a non-final state S2, since 0, 0 should not be accepted. And finally, if the input is a 0 at S2, then we'll move to a final state S3, since 0, 0, 0 should be accepted. Now we're not moving back to the final state S1 because we don't want any sequence of triples of zeros to be accepted. We just want 0, 0, 0 to be accepted. Suppose instead that the input initially is a 1, then we'll move from S0 to a non-final state and this will be a new non-final state S4 because the string 1 should not be accepted. And if the next input is a 1 at the state S4, then we'll want to move from S4 to a final state. And here we can reuse one of the previous final states, S3.